For problem solving practice, I encourage you to have your journal open in front of you. Okay? This is a very useful process if you have weak algebra skills. Even if you have awesome algebra skills, it's helpful when the problems get really, really difficult. Okay? So, here's some practice. These are concepts you have never learned about yet in science, and yet I'm going to show that by following the process, you can still figure out the answer. So, step one in the process is to identify the variables. All right, so what you're going to do is you are going to record every measurement with its units. Blah, 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 blah. Okay. 874 newtons. And then 32 meters per second squared. Again, this is step one. Okay? Now, newtons. What does newtons measure? Well, fortunately, here in the question it tells you newtons of force. The symbol for force is an uppercase F. Okay? My 32 meters per second squared measures what? Well, right here it tells us acceleration. That is a lowercase a. Okay? That we have now finished step one. We've identified all of the number of variables that's provided in the question. I labeled and identified what they are. All right? Now, step two, we need to identify the question. So go to the question and be very, very clear what it's asking for. So what is the mass of the car? The mass is the variable in question. So the question is mass. That's what we want to know. What is the mass of the car? Step three is about picking your formula. Okay? You need to find a formula that has F, A, and M in it. All right? Preferably just those three. All right? And you'd be given a formula chart, and you can look at the whole formula chart. Well, right here, I'm providing it for you, just to simplify the time here. So, F equals MA. That's going to be the formula you're going to use. Step four, you need to ask yourself the question, is this formula arranged and ready for you to use to solve for the question variable? Well, the question variable is M. So put a little question over the M in the formula. Is that all by itself on one side of the equal sign? Well, no, it's with the A. So that formula must be rearranged. If it must be rearranged, then we need to do step four, which is the magic triangle. Draw your triangle, all right? Put that uppercase T in it. Divide it into three sections, all right? Now, look at the M and A. They're side by side in the formula. They need to be side by side in the triangle. So they're going to be in the bottom two slots, M and A. That leaves F to go in the slot on top. All right, now we've done that. We've got the formula as it's given to you into the triangle. Now the question, M. Put it all by itself on one side of the equal sign. M equals, that's what we want to know. Now cover the M in the triangle with your finger. What you have left is F over A. So your formula is going to be F over or divided by A. You have now successfully rearranged the formula to solve for the question variable, which is M, mass. Now we're going to plug those numbers in. M equals, instead of F, 874 newtons divided by A, which was the 32 meters per second squared. Now you know exactly what to punch into the calculator without guessing. So now you pick up your calculator. You've done all the work, now do your calculator. All right? 874 divided by 32, calculator says 27.3125. So we're going to write that down so we can practice our sig figs. Calculator, 27.3125. Now the calculator doesn't know significant figures, but you do. So look back to your original numbers, the 874 and the 32. How many significant figures does the 874 have? It has 3. The 32 has 2. So what's bigger, 3 or 2? What's smaller? The 2. So our answer must have only 2 significant figures. So we are going to plug those numbers in. So we're going to round this to 2 significant figures. We have the 2 and the 7. Now you have to check the next one. That 3, is it going to round the 7 up or leave it alone? It leaves it alone. So 27 is our answer rounded to the correct significant figures. Units of measure, this is one of those things, when it comes to units of measure, you're just going to have to memorize this part. That you will learn with each concept and each formula we use. Mass measured in kilograms. Remember those base units? There they are. And that's your answer. You haven't learned anything about force or acceleration or any of that formula, but yet you were able to get the correct answer using the problem-solving process. Okay? Question number 2, if you would like to try at this time, you are welcome to pause and work the problem. If you are not ready, if you want to see me work through this one, just keep following along. Okay? So, number 2. Step 1, all of the numbers with their units of measure from the problem. So we have a 45J, and we have a 28 meters, which you know that's an M. All right? So, that's all the numbers I see. I'm going to read it real fast. A woman does 45 joules of work as she pushes a grocery cart a distance of 28 meters as she moves through HEB. How much force was used to move the cart? Okay, I think that's pretty much it. All right. Now, that J, what is that 45J? What is being measured there? Well, if you go back to the question, work. Work is actually a variable, and it's an uppercase W. Okay? The meters, well, you should have an idea. It says right there, waha, distance. So, symbol for that is the D. Work and distance. We have now accomplished step 1. Step 2, we need to identify what the question is asking for. So let's go, we have a question mark here. So how much force was used to move the cart? Force is our question. So the question I'm trying to solve for is force. Now we need a formula that has those 3 in it. Again, I've provided for you here, but you need to have W, D, and F in it, and we have W, D, and F in that formula, so that's the formula we're going to use. W equals FD. All right? Now, question. Step 4 is optional only if we need it. Do we need to rearrange the formula? If F is my question, if F is the question variable, do I need to rearrange this formula? Is F all by itself on one side of the equal sign? No, it's with the D. So yes, I need to rearrange. So, magic triangle. Draw your magic triangle with the uppercase T in it. Okay? F and D are side by side in the formula, so they need to be side by side in the triangle. So F and D are going to go on the bottom. That leaves W to go on top. All right, F is the question. F is what I want to solve for. F is my question. All right? So F equals is my question. Cover the F in the triangle. W over D is what you can see is left. So we need W over or divided by D. W divided by D. F equals W divided by D is our formula rearranged to solve for force, which is our question. So let's plug those numbers in. We know what W and D are, so let's plug those numbers in. Instead of writing W, I'm going to write 45J for joules. Divided by D for distance, 28 meters. Okay? So now we know exactly what to put in the calculator. We're going to do the 45 divided by the 28. Calculator gives us 1.607142857, blah, 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 blah. Okay, so correct significant figures. Go back to your original numbers. We have the 45 and the 28. They both have 2 significant figures, which means our answer should only have 2 significant figures. So the first 2 digits, the 1 and the 6, look at the third digit. Is it going to round the 6 up or leave it alone? It leaves it alone. So our answer is going to be 1.6. Force measured in newtons are units of measure. And that is the correct answer. Okay? All right, question number 3. I really encourage you to pause and try and work this problem now that I've done a few with you. Try and follow the problem-solving process on your own. All right, here we go. Car is traveling with a speed of 78 meters per second. Writing down all numbers, so our step 1 in the process. All of our numbers. Then we have a 2, 3, 9, 4, M. Okay? So a car traveling speed of 78 meters per second. How much time does it take to travel a distance of 2,394 meters? Okay? So we need to know what these two are measuring. Meters per second, we haven't learned that yet. We need to know what meters per second is measuring. So 78 meters per second, read the question carefully. It says a speed of. So that is our speed. Okay? How much time does it take to travel a distance of 2,394 meters? All right, so that 2,394 meters. Meters is a measurement, you should have used this already, of distance or displacement. There it says distance. All right, now, step 2, the question. What is the question asking us to solve for? Well, read the question carefully. How much time does it take? Time, lowercase t, time is our question. So that's step 2. Step 3, okay? Step 3 is now finding the formula. Now you know already that this is going to be the formula. But that doesn't look like it matches. Well, you've already learned about distance and displacement. Distance, this is distance, that's displacement. You know those are very similar concepts. Okay? What you're going to learn is about speed and velocity. Speed and velocity are very similar as well. This formula for velocity is almost the exact same formula for speed. The formula for speed is simply the distance divided by the change in time as well. Okay? The two formulas are almost identical because speed and velocity, that's a scalar, that's a vector, that's a scalar, that's a vector. But it's a very similar idea. So this formula can be used to solve for the speed simply because the concepts are so similar. Okay? So we're going to be using this formula because this is what shows in the formula chart. This is a concept you need to understand that speed and velocity are very similar, which you'll understand in the next journal entry. Okay, so the question is time. So step number 4, do we need to rearrange the formula? Well, yes we do, because the time is not all by itself, it's with the displacement. So let's rearrange that formula. Magic triangle. All right, so delta D over delta T. The one is over the other in the formula, so it needs to be one over the other in the triangle. So I got to put delta D on top, delta T on the bottom, and V in the empty space. Now the T versus delta T, they're pretty much the same thing. The amount of time it takes to do something, the change in time, it's pretty much the same thing. All right. So here we go. If change in time is the question, how do I get my answer? So change in time, cover it with your finger, and you end up with delta D over V. Delta D divided by V. So displacement over velocity, which, when we're talking about speed and distance, it'd be essentially the same thing as the distance over the speed, because speed and velocity are similar, those are similar. So my distance, 2,394 meters, divided by my speed of 78 meters per second. And here we go. We know exactly now what to put in the calculator. We need to put in 2,394. We're going to divide that by 78. And that gives us 30.629. Going to write that down what the calculator says. 30.6923076 blah, 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 blah. Okay? Now, significant figures. Go back to your original numbers. The 78 has 2,394 has 4 significant figures. So our answer needs to have 2 significant figures. So we need to round that number to 2 significant figures. Well, the 3 and the 0, and then you have to look at the third one, the 6. Is that going to round the 0 up or leave it alone? It rounds it up. 31. And now we're solving for time. Okay, time is the question we're solving for. The units for time are in seconds. Base units for time are seconds. If you look right here, you can also see meters per second. Seconds is a measure of time, so your seconds is right there. That is the answer for number 3, 31 seconds. Again, you can use this. You need a little bit of background information sometimes to understand and manipulate the formulas, but the process is the important thing, learning the process. And once you understand and you've learned some of the stuff, it'll be really fast and easy. Okay, so number 4, definitely pause and try and work out that problem. Okay. All right, so first step, we are going to, I write down all the numbers. 983 newtons, 743 kilograms. Identify what they're measuring. So 983 newtons. Newtons is a measure of force. It says net force there. All right, so you can write that there if you want to. It still pretty much applies. All right, kilograms, the measure of mass. It says right there. Oh, actually, you should know that. Kilograms, remember, that's a measurement of mass. So we have step 1 done. We have the numbers written down with their variables, and we've identified with their units of measure, and we've identified what variables they're measuring. Step 2. What will be the car's rate of acceleration? So we need to know the question. So rate of acceleration is the question. So our question is acceleration, lowercase a. All right, so we have a formula here. F equals ma, has the F, the M, and the A in it. That is technically F net equals ma, so that all applies, all still works. So there is our formula, F equals ma. It has the variables which we are dealing with, the ones we know and our question. So step 4, do we need to rearrange the formula? If A is the question, if acceleration is the question, do we need to rearrange the formula? Yes, we do. Because A is with M, it's not all by itself on one side of the equal sign. This formula is set up to solve for F. We need A. So we're going to rearrange the formula using our magic triangle. Draw your triangle. M and A are side by side in the formula, so we need to be side by side in the triangle. That leaves F to go on top. All right, A is question. We want to know what our question variable is, so A equals... Now cover the A with your pinky in the triangle. You're left with F over M. F over M. F divided by M. Force divided by mass. That is our formula rearranged to solve for acceleration. Plug in your values. F is 983 newtons. And M is 743 kilograms. Now we know exactly what to put into the calculator. So 983 divided by 743, the calculator gives us this lovely number. The calculator says 1.3230148, blah, 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 blah. Okay, significant figures, go back to your original numbers. I've got 3 significant figures and 3 significant figures. So our answer needs to have 3 significant figures. So we have 3 significant figures. 1, 2, 3. And then you look at that fourth one. Is it going to round up the 2 or not? No, it will not. So our answer is going to be 1.32. Acceleration is our question. So our units of measure had to be the units of measure for acceleration. The units of measure for acceleration are meters per second squared. And that is your answer. That is some practice for you on the problem-solving process. Now make sure you get that worksheet glued in to your journal problem-solving process page. Okay? In your journal, put the glue in the binding like we always do. Glue in the binding and shove it in there and make that worksheet a permanent part of your journal. Just like that.